Okay, welcome everybody to MPCS 51100 Advanced Programming. This is a class that teaches you how to program in C, but it does so not only by teaching the C language, but by exploring a wide range of interesting programming topics that allow you to exercise the C language in an efficient way to understand the structure of C programs and also to learn about a broader range of applications, programming in general, and to become a better programmer. The way I want to do this video is to have it augment the PowerPoint slides that I created. So I created a set of PowerPoint slides to introduce you to the C language, not by making them comprehensive, but by focusing on those aspects of C which are different enough from languages that are more commonly taught these days that I thought they warranted going into some depth on. So I didn't cover control structures and all data types and all of the basic aspects of the C language. There are some nuances to those things, but a lot of them are similar to whatever language you program in. So I really focused on some key concepts. And rather than having this video just go through those slides, because I think they're pretty self-explanatory, I want to use the video to pull together an example that illustrates a lot of the points that are described in those slides. And that includes things like the basic structure of a C program, data pointers, function pointers, memory allocation, how to define structure types, opaque types in general, how to do basic I/O, even a little bit of basic plotting. Okay, so I'm going to pull together these different ideas into one example that we'll build incrementally, and hopefully that together with the notes will give you enough of what you need to get started. Obviously, if you're already an experienced C programmer, you could either go through this very quickly or possibly skip it altogether. But we will immediately move in the next class to more sophisticated design issues and then very sophisticated algorithmic issues, many of which you've likely never seen before. And you'll get a chance to master your use of the language in addition to a number of these topics that are related to programming in general. Okay, so why C? I think that's a very good question. I don't think anybody would pretend that C is the typical language of choice for application level programming. So if you're in any field, want to design an application that interacts with some kind of end user community, oftentimes you could do that in a higher level language. And the higher level language often depends on the community you're targeting, but even the most general purpose high level language that has lots of libraries built in for things like graphics, built in data structures like linked lists and array lists and sets and queues and priority queues and all the things that are the sort of basic building blocks of programs. And that might have higher level operations on aggregate types, like, for example, matrix operations or object serialization. I mean, these are all very, very nice features, and they allow you, they're very expressive and concise, and they allow you to get from a starting point to the implementation of some quote unquote business logic very, very quickly. So nobody's pretending that C, in most cases, is an adequate competitor or replacement to those programming languages. So what is C good for? Well, a lot. Okay. One thing is anytime you want to program at all close to the hardware. So when you're interfacing at a deeper level with the computer architecture. So it could be things like writing device drivers, or it could be just writing very high performance code in general. If you want to optimize different looping structures, for example, I mean, there can be a lot of reasons why you want to program very close to the hardware, or I shouldn't say very, because obviously you can go much closer than C, but relatively speaking, very close to the hardware, so that you can extract something close to the theoretical peak performance of the processor, or at least the theoretical peak performance of the memory subsystem. Okay, and a lot is still hidden from you, even when you're programming. Even when you're programming an assembler, frankly, a lot is still hidden from you. For example, the caching algorithms, which are probably the biggest dictator of performance in any application, is all done in the hardware. There's nothing that you do, even at the machine language level, that affects directly what the cache is doing. So it's more of a suggestive type of programming, knowing the caching algorithms. So they take everything I say with a grain of salt, but it's all true to a certain extent, right? And so C is a general purpose language that can be used for any class of applications. It doesn't make sense these days for things that are not performance critical or that are not interacting very closely with the hardware, but there are still a lot of things that don't fit that category. And furthermore, C is very good itself to build programming languages on top of, for example. So there's still many, many uses of it. Probably the most important reason, though, to focus on C is because it makes you a much, much better program, and it makes you understand much better the algorithm hardware interface. Okay, so you have a much clearer view of what the computer sees when you execute a certain algorithm, and not just what the programmer sees. And that has benefits that are hard to quantify, but that permeate all aspects of what you do as a programmer. And a sort of related benefit is you understand a lot better the structure of many other technologies which were derived from C. And a big common example of that would be like the Unix operating system. But many other languages, even like Java, are derived from a lot of C principles with higher level constructs thrown on top. And so you'll see it everywhere. And I think it's just an important part of being a software developer, or just being any kind of computer scientist or any kind of practitioner in areas related to computer science. Okay, so that's sort of the motivation, and it is in some ways a little more subtle than it seems, particularly to evolve best practices. All right, so why don't we move directly to our example, and as I work our way through our example, I'll bring up a lot of points that are in the notes by way of illustration.